Hello everyone, this is going to be the equation game. The objective of the game is to create this equation with some number cards and then be the last player to affect the equation so both sides are equal to 1. So to first begin to create the equation, we will just draw from the numbers deck that's been shuffled. So I already did that. The first two numbers were 5 and 2, so I made 52 on the left side. And then I drew a 1 and a 3, so I have 13 on the right side. Then I put them back in and I reshuffled the deck. And now, to start the game, each player needs to draw 8 cards from the numbers deck and 8 cards from the side deck. The numbers cards range from 1 through 5, and the side cards are left, right, and both. So I already did that for both players. I'm playing by myself, but I'm acting as 2 players. And then there's the operation cards, plus addition, subtraction, multiplication, and division. And for those cards, each player draws 1 addition, 3 subtraction, 1 multiplication, and 3 division cards. And then they shuffle the operation deck. So, two things to note about the game. A special event will happen when you have the number being divisible by 9, you get an extra turn. And then when it's divisible by 10, you lose your turn. There is also, when you divide, you will round up to the larger number, so that way there is no fractions or decimals. And when you subtract, you cannot go past 1. So say part of the equation is 4 on one side, and you subtract by 5. The equation will go to -1, and therefore it went past 1. So you will negate it and you will lose your turn. So I will start as the left player, my left, and then we'll see how it goes. So I see 52, and I see that I could add 2 to both sides and make 54 divisible by 9. So I'm going to do that. Because hey man, you can do stuff. Stuff happens when you get it divisible by 9. So let's do it. Let's have some fun. You're already using your only addition card, but hey, you're new to the game. Why not try it? It's still really early in the game, and it doesn't matter. So after you play your hand, after picking 1 number card, 1 side card, and 1 operation card, you apply it to the equation, and then you put the side card you used at the bottom of the side deck, the number card at the bottom of the number deck, and then you put the operation card in a special discard pile for yourself. So let's add 2 to both sides, so we get 54 and 15. Now he gets to go again. Now he's going to play a little risky, and he's going to knock down the game a bunch. So he wants to, let's say, divide by 3. He's going to get that right side really low, so he can start playing really close to the hand. No, you only divide the left side by 3. So he'll pick number 3, he'll pick a left side card, and he'll pick a division card. So that goes in the discard pile. Let's divide by 3. So 3 into this is, what is it? It's 18. So 18 is equal to 15 is the new equation. Put these to the bottom of their respective decks. And 18 is also divisible by 9. So this player is doing pretty good without even knowing it. So what does he want to do now? Well, he wants to try and make it so he's not going to be able to get to 1 in the turns following, because even if he has no amount, if he gets this to number 9 or the 15 to 9, the only thing he can do that will do the most of the equation is divide by 5. And if you divide 9 by 5, it will round up to 2, and therefore he will lose. So he doesn't want to do that. So the player wants to bring it down to where it's close to 9 and kind of force the other player's hand to get it low enough so that way he can come in and steal the win. So what he'll do is he'll subtract by 4. He doesn't want to subtract by 5 because then he'll subtract 5 by the left side. That's actually not a bad idea. He has a lot of subtraction cards, so he has plenty of room to spare. Now, actually, when he's going through his side cards, and I notice how bad my shuffling is, I think he only has right side cards. I'm actually going from the wrong player. This is kind of confusing. Okay, so he has a left card. Now he just needs a 5 card. Does he have a 5 card? He does, I'm pretty sure. Yep, there it is. So you'll subtract the left side by 5. Put these in the right place. And now we get 13 is equal to 15. His turn is finally over. Alright, so the other person's turn, what he wants to do is he wants to do his best attempt to kind of do the same thing as this guy does. So what he can do is he can subtract 4 from the 13, get to 9, and then what he can do is he can get this number to 9 again and then divide by 1 and really stalemate the other player if he has the cards to do it. So what does he want to do? He wants to subtract 4 maybe from both sides, so he'll go to 9 and 11, and then he can subtract 2 from this side and get it to 9 as well, and then he can just divide by 1 by anything. He has a 1 and he has a 4, so he needs to subtract by 4 and then he needs to subtract by 2. So does he have a 2? That's his goal. Alright, he has a 2. Does he have a both sides card? I'm pretty sure he does. He does. So his first play is he'll play a 4, a both, and a subtraction. I'll go ahead and affect the equation now. So it goes to 9 is equal to 11. Put these in their respective decks. Now he's going to subtract by 2 from the right side. No, from both sides. He wants to kind of lower the other side a bit more. So he'll subtract from both sides. And then we get 7 is equal to 9. And then he has one more turn to go. And now what he wants to do is he wants to divide by 1 by either side to stall his turn. So he does have a 1. So he's going to divide by 1. Let's say, how many does he have? A lot of left cards. Let's see. He's going to look through his side cards. He's going to see he has quite a couple of boths. He doesn't have many rights, but he does have a bunch of lefts as well. So he's going to use a left card because he has extras. So the equation doesn't change. And now the round ends. At the end of every round, which is at the end of both players' turns, the players will draw randomly together, like so it's one draw from each deck, and then apply it to the equation. So it adds a little bit more randomness and can break stalemates, because it seems like stalemates can happen. So we'll get a 5, a division, and then on the right side. So this is really dangerous for the player that just went, because this is going to make both sides really close to being able for a win. So the 5 goes, so 9 goes to 2 then, because they'll round up. So we have a 7 and 2 now. So yeah, this is really dangerous for the player on my right side, because the equation's pretty close to being close to 1. So what the player now wants to do on the left side, he wants to see if he has a 5, because if he has a 5, he might be able to win. If you divide 5 into 7, what is it? It is 1.5. So it actually rounds up and it'll go to 2. So that's not going to work. Wait, is it? Let me double check. I gotta make sure. No, it actually round down, so you can win. He can win in this turn. No, actually, I said round up. I'm kind of confusing myself with my own rules. No, so it'll round up, so the division isn't going to work. So what he wants to do is he knows that the division won't work, so he wants to subtract, let's say, the left side by 1. So it goes, no, he wants to add, maybe he has an addition card still. So maybe he wants to add, no, he actually uses his addition card. Oh, this guy's kind of screwed. Alright, so he has a multiplication card. This is how he can save himself. He has a multiplication card. So what he wants to do is he wants to multiply by either side, maybe, by a small number, because he wants to try and win the game. So what he'll do is he'll multiply the right side by 2. That's what he'll do. So this is the only multiplication card, so he's really out of options if the equation goes out of balance again. But this way, he can stall. Because anything he would have done, minus or division, he would either lose his turn, which might not be a bad strategy, or the other player would easily take the win. So we're at 7 and 4 now. So this player on this side now, to my right again, needs to figure out how to handle this. So as I'm thinking about it, I see that having an addition and a multiplication card may kind of make things go way too long and way too much in a stalemate. It could just continue onward. You could easily get people that just want to forestall the game. And there's also this thing that the special events of 9 and 10 are a little bit too high because the numbers only go to 1 to 5. So the 9s, and between 9 and 5 there's almost like this dead space, it seems like, and therefore they can't use the special events to really grab a win. So one idea before I go back into playing is to maybe lower the special events to a smaller number, like let's say maybe 6, maybe 7. No, maybe actually 7, because 7 they still can't necessarily win right afterwards. But then again, do I want that or not? I'm still deciding. But anyway, let's continue onward. So this person now, he is gonna take a dare. Since he only has 3s and 1s left, he actually only has 3s and 1s. So he's really short on options. So what he wants to do is let's do subtract by 3 on the right side and get one side to 1 and really scare the other player. Now he's not sure what this side will do, but he's hoping it will be to his advantage. He's kind of gambling here. There's going to be some gambling as you get to the end because of this end of the round play. So anyway, you'll subtract to the right 3. Put this away, put this away. So now the equation is 7 is equal to 1. So now that the round is over, we do another draw. So we get 5, multiplication, and left side. Oh man, that really throws things for a loop. So now it's 35 is equal to 1. So I'm nearing the end of my demonstration. So with this in mind, let's think about this. So what this player could do. Actually, there's not much more the player can do. He could try and add 1 and get to a 9 and then go from there. Or he can try and divide by 5, get it to 7, and kind of stalemate it again. That's not a bad play. But so far, I think it's really interesting, this game. I think the addition, with the addition of the multiplication and the addition cards, it kind of can stalemate for too long. No one will end up winning, and it might draw on and kind of people get bored. So I'm thinking about maybe getting rid of multiplication and addition entirely. I've also thought about making it so the objective is the players try and get their respective sides to 1 instead of both sides. So the first player only tries and gets the left side equal to 1, and the second player gets only the right side equal to 1. Now, as you can see, there is really no game board right now. I'm still deciding if I want to do a game board or not. I kind of want this game to be almost like Yahtzee, where you just pull up maybe a scorecard or some type of device like a dial thing for the equation, so it's really easy to keep track of, and then just some cards to represent the numbers, operations, and side cards. So that was my game. Let me know what you think, and thank you very much.